13, that is the entire count of root server names holding up every single lookup on the internet, every website, every app, every email. 13 names. Today we find out how that number is nowhere near as fragile as it sounds. Our story starts with a resolver facing a name it has never looked up before, example.org. No cache entry exists anywhere. It has to start the hunt completely from scratch. Every resolver on Earth ships with the same small cheat sheet, the root hints file, 13 addresses baked in since the software was installed. Those 13 entries point to the root servers, the very top of the DNS tree, the first stop for any name the resolver doesn't already know. Here is the twist: each of those 13 names is not one computer. It is answered by hundreds of identical copies, scattered across the planet, Tokyo, Paris, Ohio, and hundreds more. A trick called anycast makes the nearest copy answer automatically, no matter which of the 13 names you asked or where on Earth you are. And when a copy answers, it never actually knows the website you want. It just hands back a referral, a pointer to the next server down the chain. 13 names, hundreds of copies each, one narrow job, point, don't answer. Let's follow one lookup from a cold start in slow motion. Take 1, your resolver receives a request for example.org. It checks its own memory and finds nothing. This exact name has never passed through here before. With nowhere else to turn, it opens the root hints file, a tiny list, rarely more than a few kilobytes, listing 13 names, letters A through M, each paired with an address. It picks one entry from that list. It genuinely does not matter which, since all 13 answer with the identical information, and sends its question there. Now the part that makes 13 enough for the whole planet. That one root name is not a single machine sitting in a single data center somewhere. The very same name is broadcast from a copy in Tokyo, answering local resolvers across Asia with identical data, all day, every day. An identical copy sits in Paris, serving Europe. Same name, same answers, entirely separate hardware, entirely separate power and network connections. And a third copy sits in Ohio, serving North America. This one root name now has at least 3 faces, and in reality, hundreds more worldwide. The technique behind this is called anycast. The exact same address is announced from every single copy at once, and ordinary internet routing quietly delivers each request to whichever copy is closest. Your resolver never chose Paris on purpose. It just asked the root name's one address, and the network itself steered the request to the nearest living copy, usually a handful of milliseconds away. That nearest copy answers, but notice what it does not do. It never says, here is example.org's address. It has no idea. Its whole job is one small referral. The referral simply says, I don't know .org, but I know exactly who does. Go ask these servers instead. One hop closer, nothing more. And that is the entire secret. 13 names never needed to hold the whole internet's worth of answers. They only ever needed to hold 13 short lists of pointers. Multiply those hundreds of copies per name by 13 names, and the real machine count behind only 13 reaches well into the thousands, scattered across nearly every country on Earth. The 13 names themselves are lettered A through M, a naming convention frozen in the internet's early days, long before anyone expected the system to outlive entire companies. Each letter is operated by a different organization entirely, universities, government agencies, and private companies, on purpose, so no single outage or single company failure can take the whole layer down at once. This independence is deliberate redundancy at the deepest layer of the internet. 13 names, hundreds of physical copies, 13 separate operators, no shared point of failure. The root layer changes almost never. Its list of 13 names has stayed essentially fixed for decades. Stability at the top is exactly what lets everything built on top of it keep working without surprises. 13 names, each broadcast from hundreds of copies worldwide via anycast, each one only ever pointing you one step closer to the answer. That's how 13 names run the whole internet. Thanks for watching. Now you know the internet's shortest, sturdiest list. Check out our video on how DNS finds websites and follow how it all runs for more. See you in the next one.